So hi everyone, and welcome to the Earth Systems and Climate Change Hub Science webinar series. We have quite a few people attending today and a few more trickling in, but I think we might just get started. So this is part of the Earth Systems and Climate Change Science Hub's webinar seminar series. And on today's webinar, we have John Clarke talking to us about climate analogues, a way to experience the future climate. John is part of the outreach component of the Earth Systems and Climate Change Hub Project 2.6, which looks at regional projections, science information and delivery. And John has a wealth of experience, almost a decade worth in developing and delivering climate change projections. And so I think without further ado, I'll pass over to John. Just as we go along, if you have any questions about the seminar, please do just use the little chat box that should be on the right-hand side of your screen. Write any questions down on that side, and then at the end of John's seminar, we'll address the questions at the end. John is giving a live demonstration of the Climate Change in Australia website, which hosts our national climate change projections. So he will be providing, going through the website rather, as he goes through his seminar. So without any further ado, I'll pass over to you, John.
Great, thanks Sonia, and welcome everybody. So yeah, welcome to the Climate Analogues tool, and as Sonia said, I'll be showing you a live demonstration initially, so let's just jump into that. I'll figure out what I'm doing here. So with a bit of luck, you can now see the Climate Change in Australia landing page. Before we launch into the Analogues Explorer, I'd just like to show you a couple of things about the website in general. So to begin with, there's the URL at the top, www.climatechangeinaustralia.gov.au. And if you haven't had a look at the website before, I would encourage you to do so. It's pretty comprehensive. A couple of things to note is that, sorry, we seem to have some problems with the website. No. People are not seeing the screen. That's weird. Maybe if anybody can see the website, can you let us know? I'm getting lots of messages that people can only see grey.
Okay, somebody can now.
Okay.
It might take a minute or two just to load.
Yeah, let's just pause for a little bit. Can you let us know in the chat if those of you who haven't been able to see it, if it appears? Some people can see the cursor. One person has refreshed and can now see the website. So if you're still not seeing it, please try refreshing. Yep, we seem to be getting a few people saying that now it's working. Yep, refreshing seems to do the trick. Great, that's a relief. Just waiting on a couple more messages. And yeah, okay, so it seems to be a consistent message. Cool, thanks everybody. All right, back to it. So the first thing I'd like to point out with the website is this discreetly hidden main navigation area up the top. If you move your mouse cursor up to the top, this mega menu pops down. The reason for showing you that is that regardless of what part of the website you're in, you can always find this mega menu and jump between sections. So it's quite handy. As soon as you take your mouse away from there, it disappears again, and it's just up here. I'll just show that again, up where it says View Main Navigation. If you hop up in there, there it is. Right down the right-hand end of this, you'll see it currently says Sign Out. That's because I'm currently signed in. To access a lot of the features within the website, you need to be registered, particularly if you are wanting to download data sets. That's really important for us because if we develop new data sets or if we need to modify existing data sets, or especially if we find any errors in data sets, and sometimes these propagate through from the sources of some of the data that we've used, we need to be able to notify people who may have downloaded those data. So it's important that people are registered for when they obtain data sets. You don't have to be signed in to access the Climate Analogues Explorer tool. So it's one of the tools that you can access without being a registered user. Now on this landing page, you see there are 4 big swatches in the top row here. They represent the 4 main sections of the website, and the labels are fairly self-explanatory. Getting started is where you go to get assistance with how to use the website itself and some of the data sets that it contains. The Climate Campus is more about learning about the underpinning climate change science and about modelling and projection science. And there's a little bit of interaction between the Getting Started section and the Climate Campus. You'll find some of the links take you between those 2 zones. The projections and data area is the largest section, and that's where, as the name suggests, you go to get hold of data sets and so forth. And that's where the Analogues Explorer tool sits. There are 14 different web tools on the website, and they all sit in here in the projections and data area. And finally, there's an impacts and adaptation section where you can go to see the types of work that's been done throughout the country in the different natural resource management regions around the place. Below that are another 4 smaller swatches, and these are simply shortcuts to particular pages within those 4 main sections of the website. And you can see there's a news and updates section, so I'd encourage you to visit regularly. That's where we'll let you know about new developments that have occurred on the website, new tools, new publications and things. And some of the notifications about changes to data sets will go in there, but if there's anything that's really important, we will notify every registered user by email. We're able to keep this website running, incidentally, because the NESP, Earth Systems and Climate Change Hub, is funding the ongoing maintenance of this website. Some of you who've been around for a while will remember that this website was developed under a separate project called the Natural Resource Management Project, or the Climate Change in Australia for Australia's Natural Resource Management Regions Project. But it's really important that when websites like this are developed, they're not just left in a static state to languish and eventually become irrelevant, particularly a website like this one. So it's fantastic that the NESP Hub is funding the ongoing maintenance of this, and the Analogues tool that I'm about to show you today has just been updated. So if you have looked at it previously, you will see that it looks a little bit different from the way it looked last week. All right, so let's dive in. We'll go into the projections and data section by clicking on the big swatch. Takes us to the landing page. Now, you may have noticed that as soon as we arrived on this page, another menu appeared. The mega menu at the top is still there, as promised, but now we have this second tier menu. Now that's a menu that's specific to the projections and data section of the website. If we went into another section, that second tier menu would look different, but this is all about projections and data. Obviously today we're here to talk about the Climate Analogues tool, so I'll go in here. Firstly, just a little bit about what Climate Analogues does. This is a technique that's been around for quite a long time, and essentially the approach is to use a space for time kind of analogue, whereby you can gain an understanding of what the future climate might be like for a location that you're interested in by looking for places, potentially anywhere around the world, where the future climate for your place is the current climate in another place. So in the illustration here on this page, you can see that it was suggesting that under a certain set of circumstances, the climate of Melbourne would become more like the climate of Dubbo. Now, we could have made this tool pull up locations from anywhere around the world because we have access to those types of data, but it's most relevant, we thought, to keep it focused on Australia. One consequence of that, of course, is that for some locations, there will be no future representative anywhere within the current climate, particularly for some of the locations that are already extremely hot. Okay, so I'm going to hop into the tool now. There's a button here that we can click to go in, or we can go back to the menu and click on Analogues Explorer. Either of those takes us to the same place. Now, depending on the settings of your browser, this is one of the new features that we've just added. It can be location aware. So if you are happy for the browser to know your location, you can click allow, or if, depending how your browser's set up, you may not see this prompt. So I'll click allow, and it took me too long, so it has defaulted to the fallback, which is Sydney. If I refresh that screen, it's now selected my location, which is Melbourne. So straight up, it's showing me climate analogues for, well, in this case, Cranbourne, because that's where it thinks I am, at a high emissions scenario in 2030, so the near future, for a climate scenario described as maximum consensus. These climate descriptions are based on a climate futures approach that we've applied for the projections across Australia, and you can find out a bit more of that in the Climate Campus on the website, which I can show you in a second. But basically what it's doing at the moment is showing us that for Cranbourne, under those conditions, we have a range of matches. You can see here there's a number of dots, and by hovering over some of those dots, it gives me some details about those places. It's a bit hard to see them though, so I can zoom in by double clicking on the map, or if I scroll back up, you'll see there are controls for zooming up in the top left corner of the map window as well. I can zoom in a bit further. If I want to, I can drag the map now so that I can see the area that contains data I'm interested in. So you can see we've got about 1, 2, 3, 4, 5, 6, 7 matches for Melbourne under those circumstances. And if I scroll down, you can see those analogue towns are listed. Bairnsdale, Lakes Entrance, Narooma, Moe, Eden, Traralgon and Merimbula. Above that, there's this section here with temperature change and rainfall change slider, and they have been preset to match the settings that we have up above in the preset scenarios area. Now I can tweak those if I want, but at the moment they represent the mean of this future climate based on these settings. But I could just drag these if I want and change them, and if I drag them enough, you'll see the map shifting. Notice though, if I drag the slider outside that orange band, I get a warning pop up. And if I hover over that, it just says, warning, you have selected a value outside the range of this scenario. So basically, we're no longer looking at a plausible future climate scenario based on climate projections. We're just looking at some hypothetical combination of rainfall and temperature change. If I bring that back to where it was, we've got the same result as we had before. Now what that's doing is it's comparing the current climate of Melbourne, which I can't get yet, but I can get the current climate of these other localities based on, at the moment, just annual future climate. So what we've done is we've taken the projected changes from the global climate models and we've applied those changes to the CSIRO Bureau of Meteorology gridded temperature and rainfall data set for Australia. And it's a gridded data set at 5 kilometre resolution at daily timescales most of the country and at monthly timescales for the whole country. And we've used those to produce plausible future climate data sets. And from that, we can calculate these future temperature and rainfall values for these locations. And at the moment, it's showing us matches based on just the annual temperature and rainfall. But you can see there are other data available. There are seasonal data as well. And we can refine the results if we want to based on those seasonal data. So if I click on this little chevron button in the top right of the map window, a bunch of settings pops out. You can see there that it has seasonal temperature, the annual box is ticked, and under seasonal precipitation, i.e. rainfall, the annual box is ticked. We can tick any of those other boxes if we want, but also the percent rainfall in summer box is ticked, and that helps to refine the results. One of the advantages of that is it prevents a match between, say, a temperate locality and a tropical locality based on how much rainfall falls in summer. But if we wanted to, we can further refine this. So let's say we're especially interested in autumn rainfall. If I tick the autumn rainfall box here, we've lost 2 localities out of our matches. Just hide that dialog for a second. So you can see now we only have 4 matches. 2 of the matches that we previously had have disappeared because they don't match closely enough to autumn rainfall. But I'll bring this options panel back out. It's important to have a look at this section on the right here, where it gives us a number in terms of percentage, and that's the tolerance within which the data have to match. So at the moment, it's showing us locations that match Cranbourne's autumn rainfall of 183 millimetres, but plus or minus 20%. So you can see we've got a result of 181 there for the future, and so that's the projected future value for Cranbourne, and so it's showing us any location that falls within 20% of that. If I refine that a bit, we should start to see more localities disappear off the map. There we go, we've just lost one. And if I keep going, we've lost another one. By default, these are set to 20% because that's a reasonable compromise. But you can use this approach to essentially narrow it down to a single match if you want to. Similarly, I can wind back the annual rainfall tolerance, and by bringing it down to a 7% tolerance, I've now got only one match. So that's pretty useful. And it's, whoops, if I scroll down, it lets me, now matching with Moe. So under these conditions, with taking autumn rainfall into consideration, it's indicating that climate of Cranbourne under high emissions in 2030 in this maximum consensus climate storyline is matched to Moe. Bring that back up to 20, we get our previous matches back. Turn off autumn, and we've got our 6 back. This other option down here under seasonal differences allows us to filter out based on the difference between summer and winter temperature. Now, this is also a useful way to improve the quality of the match if you've got too many matches. So if I tick that, let's see what happens. So that has knocked out 3 localities. And if I scroll back down, yeah, Moe is still among the 3 that we have. So you can see how by just modifying these settings, we can refine the matches and ultimately get down to a single match if we want to, if that's desirable. Now if we do that, just refine it back down a bit. Points about this is that if somebody tells you, oh, it's going to be, what does it say down here? 0.8 of a degree warmer and, well, about the same in terms of rainfall in the future. What does that really mean? And it's difficult to conceptualize just what it really means. So the advantage of this approach is that there's a really good chance that you've been to Moe, if you live here, or Traralgon, or whatever that place is, Bairnsdale. Really good chance. And if you haven't been there yourself, you probably know people who have, or you've probably heard about it. So this is a way of kind of experiencing the future in your mind without actually having to be in the future, because of that experiential kind of comparison that's drawn. And you can build on this if you want by bringing in additional information. So if you know, say we look at the narrowed down results where it showed us a good match with Moe, you can start to explore, well, what's life like in Moe? Start to look at pictures of Moe, start to find out about the industries, the agriculture and things around that area, and start to form a picture of what the future is expected to be like under this particular set of circumstances. Now you can do this for any part of the country. If we zoom the map back out, you can see anywhere there's a dot, we can provide data. Now, in principle, we could provide climate analog matches for any point on that 5-kilometre grid across the country. But given that one of the key purposes of this approach is to allow you to have an understanding of what the future climate might be like, then for us to say, oh, the future climate of your town is going to be like the future climate that can be found at 150 degrees east and 32.5 degrees south is pretty meaningless to anybody. So we have restricted the search results to named localities. And we have about 400 plus named localities in the system that it provides matches to. So there's a good chance that you'll find a match somewhere that will make sense to you. To match up to other locations, you can just click on the map, and now it's using that location instead of the one that it had chosen by default. Or you can use this selector here and choose from any of the 400 plus localities. Now, while I've got that open, if I just type, I don't know, letter S, it jumps to S in the alphabetical listing, and I can quickly find what I'm looking for. If I type ST, it'll take me to the second, interestingly, of the STs, which is in Queensland. So that's how you choose your location. We also have a choice of emission scenarios. Now, by default, it's selected this high emission scenario, RCP 8.5, but you can also choose from these other two. RCP 2.6 is the lowest emission scenario for which we have data. It's the lowest of the scenarios that were developed for the last IPCC report. Then there's RCP 4.5, which is higher by and large than RCP 4.5, but not as high as RCP 8.5. The reason it shows RCP 8.5 by default when you first load the page is partly because that's pretty much the RCP that we've been tracking globally for the last little bit over a decade. There's some indication that perhaps we have started to drop below that in the last couple of years, but we need to wait and see a bit longer just to see if that continues or whether it comes back up again. But more importantly, at this future time period, 2030, the choice of emission scenario makes virtually no difference. So we choose RCP 8.5 and 2030 by default. If we choose a future time period though, and we have two others to choose from, mid-century or 2090, if we select 2090, we're going to see much bigger differences. You can see what happened to the map when I changed it to 2090. St George becoming like Whitnoom Gorge. I don't know if you've been there, but it's pretty hot and dry. Now, of course, if I change the RCP, let's say I change it back to 2.6, you'll see a big difference. If I go to 4.5, you'll see it changes quite a bit. In fact, we didn't get a match at all. If I tweak the settings, I probably will get a match. But sometimes you won't get a match, and that in itself is an interesting story. You know, there's nowhere in the country that looks like the future climate for where you live. I'll leave it on that though, and I'll just look at this description here. What we've done is we've pre-selected 3 future climate scenarios for each of the NRM regions that we use to develop these projections. And by default, it shows the maximum consensus. That's essentially the future climate that is represented by the greatest number of models. And there are 40-odd models in the mix. But we might be interested in a more extreme case, like the hottest and driest. And if we do that, you can see that we've gone back to a match over in WA for St George, even in this intermediate emissions scenario. What happens if we go to RCP 8.5? This picks a slightly hotter, drier spot. Back to Whitnoom Gorge. That's interesting. That suggests that at the end of the century, under the highest emissions scenario, the hottest and driest scenario is actually the same as the maximum consensus scenario. If I choose that, you'll see the results haven't changed. If we look at the least hot and wettest, if you like the most optimistic projection for highest emission scenario towards the end of the century, we get different results again. And again, no match. Because there's no match, let's have a quick look at the settings. And if I turn off this summer-winter temperature difference, what happens? All right, put that away so we can see it. Now we've got some results again. So that's interesting. Summer-winter temperature difference reduced the number of matches quite dramatically. Okay. Now, there's some terminology here that I've explained a little bit, but if you're not familiar with things like emission scenarios and this, particularly this climate futures description, which I'm sure many of you won't be, there's information down below this tool. Now, this is typical of all of the tools on the website. We've always put some descriptive and instructional information underneath the tool. So with any tool on the website, always scroll down and just have a look at what's there. There will usually be a getting started section that explains how to use the tool pretty much, how to get going, and then some more detailed explanation of each of the different settings that you can apply with the tool, including these advanced options. Pretty much every tool has some additional options that you can use. Some are pretty simple, like just changing the regionalisation scheme on the map. Others, like this one, are more complex. In fact, this has the most complex set of advanced options of any of the tools on the site. And then a few tips on how to navigate using the map. And then importantly, methods, how the tool works, the way we've gone about it, because with any of these things, there are more than one way to skin a cat. So you need to have some understanding of how the tool does what it does, and really important, the limitations. So the key thing to remember with this tool is it's not a detailed impact assessment tool. It's not providing enough information for you to make a decision about whether or not you should continue in your current business at your current location or whether you should move somewhere else. But it's enough information to get you started on that thinking process to help guide where you might need to put a bit more effort and a bit more planning to get a better understanding. Now, if I go back up, we'll find there are also links to some key bits of information. So if you don't understand this emissions scenario language, then you can click on the link, takes you to another page, which is this page here, which explains those emissions scenarios. Similarly, if you want to know more about the climate futures approach or the ways in which the regions are defined, you can use the links. Here's the link to the climate futures approach, and here's the link to the regions that were used for the NRM work, which is this one here, explains why those regions are the way they are and how they were used in the projections work. If we just go back to the greenhouse gas emissions scenarios, two things that sometimes confuse people with emissions scenarios, and that's the distinction between emissions and concentration. So emissions is, as the name suggests, basically a measure of how much greenhouse gas and other chemicals that have an effect on the climate are being put out into the atmosphere over time, at any period of time. And so in this plot, you can see that it's showing us globally mixed emissions for the whole of the 21st century, from 2000 to 2100, under the 4 different emission scenarios that we. So remember, that's about how much greenhouse gas and other gases we're putting up into the atmosphere at a point in time. The plot on the right, however, shows the well-mixed concentrations of those gases in the atmosphere over time, and again, the 4 different emission scenarios are shown with those 4 lines. It takes a while for the greenhouse gases that have been emitted from a location on the planet to get up into the atmosphere and to mix evenly all the way around the globe. And so there's a lag effect between the emissions and the concentrations. It's important to understand that when we do climate modelling, the climate models need to know this concentration information. The climate models only indirectly take account of the emissions in terms of how they've been translated into well-mixed concentrations in the atmosphere. Most of the conversation that you hear in the media, of course, about Paris targets and so forth are really focused on emissions. So it's important to realise that there's a distinction between those two things, and they are intimately related, of course, but they are different, and that's why sometimes the terminology can be a bit confusing. And in terms of the emissions pathways, representative concentration pathways is what they're called, then the tool that we've just been looking at, the Analogues Explorer tool, allows us to explore this one here, RCP 8.5, RCP 4.5, and RCP 2.6. Incidentally, if we are to have any chance of achieving the Paris Agreement target of 2 degrees, this RCP 2.6 is essentially the type of pathway that we need to follow. But another important thing to remember is that the reason we have these emissions scenarios or representative concentration pathways is because we don't know the future. We can't know the future. It's impossible for us to know what the greenhouse gas concentrations will be in the future at a point in time. So what we have to do is create some essentially what-if scenarios. So the RCP 8.5 you can see described here. Essentially, the premise behind this concentration pathway is that it's a future with little curbing of emissions. with a carbon dioxide concentration continuing to rapidly rise, reaching a certain number that's really big by the end of the century. Whereas in stark contrast, RCP 2.6 down the bottom starts out by saying this is the most ambitious mitigation scenario. Mitigation is the terminology that's used to describe what we do to reduce our emissions and ultimately, therefore, the concentrations in the atmosphere. This is about emissions peaking early in the century, around 2020, that's like 2 years away, then rapidly declining. Such a pathway would require early participation from all emitters, including developing countries, as well as the application of technologies for actively removing carbon dioxide from the atmosphere. And CO2 concentration peaks before declining again later in the century. So, and there's a link here to scientific paper if you want to read it. So the information that explains some of this stuff is all here, and make use of it. So I'll just quickly check my notes to see what I've missed. I don't think there's anything I've missed. I'll just switch back. So essentially, summarizing, there's the link to the Explorer tool if you want to go straight to it. It's long and clunky, so you could just Google Climate Analogues Explorer and you'll find it pretty quickly. Should be the first hit. The tool is essentially about communicating the future climate in what we refer to as an experiential way, using space for time analog approach. Remember that it's based just on expected changes in rainfall and temperature. It has not taken account of any other climate factor like wind or evaporation or humidity. Importantly, if you're looking to use this tool to help guide your initial thinking around agricultural applications, it hasn't taken soil type into account, neither has it taken account of soil moisture, although there are obvious links there with rainfall. So just be aware that while it's a great conversation starter and a first step towards the adaptation process and a really good communication tool for getting key messages across, it's not a detailed assessment. So really importantly, don't overcook the results. And the other key thing to remember is that it lets you explore the future climate, not only in terms of greenhouse gas emissions and time in the future, but also these 3 climate futures or climate scenarios that we've chosen that are useful ways of looking at the possible range of changes across the country. So that's it. Thanks very much, and I'll try and answer some of the questions.
Great, thanks, John. We do have a couple of questions and a few more coming in. So I'll just kind of start from the first question that came in, which was from Michael. He just wanted to check that when you hover over a node in the tool and it comes up with some data, is that the current data or is that projected data for that location?
Great, yeah, really good question, and I should have covered that, so thanks for raising it. Before I answer it though, I've just remembered there was something I forgot to mention, and that is that Liz Hamilton is on the webinar, and she's used this approach to develop some posters for various towns in Victoria and Southern New South Wales. You can see this in the chat stream. Apologies, Liz, I meant to actually have a slide showing one of your posters, but I recommend you have a look at that and see the work that Liz did, which was really good. So to answer the question, I'll jump back to the tool. I hope it doesn't take too long to come up this time, and go back into that option. Oh, sorry, when we hover over the towns, that's what the question was about from Michael. So when we hover over a town, it's basically showing the current climate as it is represented in the gridded data set that underlies the method. Now, if I go down the page again, find it quickly. Yeah, you'll see down here that it talks about the climatology underlying is seasonal average temperature and rainfall centered on 1995 from AWAP, and there's a link to the Bureau of Meteorology website that talks about that AWAP dataset. There's a few things to remember to keep in mind with this dataset. It's not the same as station data. So if you, for example, if I go back to the map, if we looked at the Bureau of Meteorology climate data, the long-term climate averages from Windora, it's unlikely that the numbers would be exactly the same as those that are on the screen at the moment. That's because in order to produce a data set like the AWAP data set, which is at a 5-kilometre grid, and I'll just zoom out, which will help you understand why. What it has to do, take the station data and then try and infill all of the space in between the stations at a 5-kilometre resolution. Now, the methods that are used to do that are pretty seriously scientific and very robust, but like any of these approaches, there are some decisions that have to be made about the way in which the data are processed and the way in which the interpolation is done. Now, when you get into a region like the southeast of Australia, or the southwest even, where there are bureau stations quite densely packed, you're going to get a gridded result that is a closer match to the station data than you will out in the arid zone where the locations are very sparse. And in fact, if you go and look at the AWAP data set for daily data, you will find there's a great big hole about where I've got the cursor, because the stations are just too far apart to be able to interpolate at a daily time step those data with an acceptable degree of accuracy. So those data just haven't been provided. But at the monthly time step, those data have been provided, which is what enables us to grab results for Warburton, for example, or Telfer. So to answer the question, that's the current climate, but it's the current climate as represented from AWAP, which will be slightly different from the station data. And depending on where you are in the country, those errors vary in size, as I kind of alluded to, but it's also related to the region. So in Darwin, for example, we know that some of the differences are fairly large between AWAP and the Darwin station, but elsewhere in the country they are much closer. There are alternative approaches to doing that interpolation, and in Queensland they've developed a data set called Silo, and that's done using a different methodology which is tuned to better match the stations, but you get a less reliable area average from their result than you get from the AWAP. So it's a matter of choosing the right data for the right purpose. So hopefully that answers your question. In terms of future data, that is shown in the pop-out, the options pop-out. It shows you the future data.
And while you're just talking about that, John, the next question was around when you're talking about the current climates, what's the time frame for that? Like 1950 to current or 1990 to current? From Tim.
Okay. Yeah, that's a really good question, and obviously it's crucial because what we've done is we've calculated the future change in climate. That implies that, thanks Liz, that implies that you've got an historic baseline against which to measure that change. And of course, your choice of historic time period will influence the size of that change. And in the international negotiations, like the Paris Agreement, for example, you'll hear them talk about pre-industrial as the reference point. But for the projections that are used around the world, developed around the world for the IPCC work, there's a much more recent time period used. So I've just scrolled down to where it talks about, hang hang on. Oh, it actually says it here. That wasn't what I was looking for, but just by chance. There it is. So the reference period that we use is 1986 to 2005. Now, this is slightly complicated. It's a 20-year period, but anybody who's done work with historic climate is probably aware that the World Meteorological Organization defines a reference period as 30 years. And that's because when you're working with real climate data, you've got to span a sufficiently long period of time to smooth out the natural variability, which, as we know, for some countries like Australia, can be really very high, particularly for rainfall. However, climate models are designed to model climate, not weather. So for them, and because we're trying to detect trends in the results, we use a 20-year averaging period rather than 30. That has the advantage of doing less averaging out of the trends, so it tends to pick up the trends better, but also because we're fundamentally modelling the mean state of the climate, 20 years is deemed to be appropriate, and that's an international standard that's used. That 1986 to 2005 period, anybody who's been watching this space for a while might remember that for the previous set of projections that CSIRO and the Bureau of Meteorology did in 2007, we used a different baseline, but we always use the baseline that aligns with the most recent release from the IPCC. So in the fourth assessment report from the IPCC that came out around 2007, they used the reference period of 1980 to 1999, whereas in the fifth assessment report that came out in 2013, they used this period, 1986 to 2005. So consequently, we switched to that for our latest work. Don't know what will happen with the next set of projections that come out for the IPCC. It's likely that it won't change, but who knows? It's a decision that will be made by the international community.
All right, well, the next question comes from Liz, who asks that given that projections of rainfall changes are less certain than temperature, are we not better to do any refining of the analogue tool based on temperature rather than rainfall?
Yeah, it's a good question. Yes, the projections around rainfall are certainly have a much broader range in them, and in some parts of the country the information is really quite confusing because there are as many models projecting a decrease in rainfall as there are projecting an increase, say in the top end of the territory, for example. That's where this climate futures approach becomes really valuable, because it allows you to explore the projection space in a way that you can readily understand. And by readily understanding, I mean, and I'll just switch to this page that explains the approach. There's a PowerPoint presentation you can download as well, which explains this in much more detail. But if I just scroll down to here, it gives a sample of the type of output that the approach produces. And what it's doing here is it's showing us the results from, in this particular example, 30 global climate models and 6 downscaling models in terms of the projected changes in rainfall and temperature. And it gives a very easy to understand visualization of the way in which there's a range of change among the different models for different variables, and allows you to focus in on a particular part of that projection space that makes sense to you for your application. So if you're growing crops, for example, you're very likely to be interested in worst case that you might need to evaluate, which is likely to be the hottest and driest kind of future that is projected. So something like this drier, hotter example, or this much hotter little change example. You might also be interested in this one over here, where a small number of climate models project a wetter climate with a smaller amount of warming. And you might call that a best case if you're growing wheat, for example. And you're probably going to be interested in this one in the middle, hotter and little change, because there are almost half of the global climate models indicating that that's a plausible future climate. So you can use that to get around the issue of the variability in the rainfall. Having said that, there's no reason why you shouldn't use the temperature change information, because yes, the temperature change information has higher confidence attached to it than the rainfall information does, with some exceptions. And it's difficult to cover this right now, but the confidence that we place on projections for rainfall varies across the country, ranging from, as I mentioned, the top end, the northern part of the country, where our confidence in both the direction and size of the changes is quite low. But at the opposite end of the spectrum is southwest WA, where our confidence is high in both the direction, decline, and the magnitude of that change, because there's a strong agreement among the models, and that aligns very strongly with what's been observed, and it also aligns with our understanding of the climate systems that drive this kind of change. So you've got to also take account of what part of the country it is that you're looking at. And the story for Southeast Australia is more complicated than that, but there are projected changes in winter rainfall that are really quite robust. So if you took into account winter rainfall for a location in Southeast Australia, then you can do that with more confidence than you could if you were, say, looking at the top end, for example. I hope that answers the question.
Okay, so there's been a few comments as well, and Robert McLean asks whether you can bring your message about the tour to Shepparton. So maybe that's something you can follow up with him.
Yeah.
And also, why not? And Pep asks whether the tool allows any sort of chat function or something where people could leave commentary, so you could collect some insights and different examples.
I would love to do that. I haven't really talked about what other developments we'd like to make with this tool, but one of them is we want to steal Liz Hamilton's idea of using photographs to enhance the description of the future climate, because there's nothing like a picture to help you gain a better understanding and build on that sort of quasi-experiential idea. Comments is a little trickier because necessarily our response time would be fairly slow. However, you can contact us really easily, and again, I'll sort of, I'll say thanks to the NESP Hub again, because of the support that NESP has provided, we're able to still operate this contact us kind of service. So if you have particular suggestions or comments you want to make, go to this contact us page, or just email me directly if you want to. But if you use the contact us page, it will go to somebody irrespective of whether I'm at work or on leave. So you can go through the CSIRO inquiries here and send them a message, and they know who to send the requests to. So yeah, feel free to use that. There's also a Climate Futures email address, which is linked here, and you could use that as well if you want to send it direct to us, and that goes to 3 of my team. So there's always one of us on deck at any time. I will say though that we're extremely busy and we're a very small team, so our response times can be a bit slow, so please be patient. But yeah, we will answer every email we get.
Great. And then we have David Caroli asks whether you can comment on the few towns or cities that don't have a future analogue in Australia for a high warming scenario, that might have an analogue in other countries or continents?
Yeah, thanks, David. It's a good question, and it has come up before. So I'm just trying to think off the top of my head. I've got a feeling that if you go somewhere like Derby or Port Hedland, it's quite easy to get the tool set so that it doesn't show you any matches. It's, you know, and it just makes sense. You know, we've got a warming climate, and if that's the key driver and there's nowhere hotter than that location in Australia, then it's not going to give you a match. You might, you know, you can conceive of matches being in the Middle East and places like that under really extreme circumstances. But I haven't put a lot of thought into that. As I mentioned at the outset, we could have designed this tool to provide international matches. We didn't. And I said we could have because we have access to those data. And yes, we could have, but we couldn't have done it at that 5 kilometre scale of resolution because those data, well, actually there are data out there that we could access, but it would start to get very computationally intensive. Maybe we could give some thought to just identifying those locations that don't give a match, and we could have a little pop-up that just says there's no match in Australia. You'd have to go to insert name of town here to find a matching climate. So yeah, that's something we should give some thought to.
Okay, just considering the time, we might just finish with one last question back to Tim about baselines. And he says that given the general use of the analogue, would there be any thought to giving users a number of baselines to pick from? For example, 1988 to 2017, which is a 20-year period that would capture the recent really hot years.
Yeah, okay. Really good point. One of the limitations for us is the availability of projections data from the models, and basically not just the projections data, in fact, but also the historic data that are available from the climate models. So when they do this modelling, they choose, the international community chooses an historic period that will be modelled and a starting point for the future period, and depending on the resources available to the modelling group, they'll simulate 100 years or maybe 200, or in some cases even more. So we are constrained by the historic data that are available from the models and the starting point for those future data. So we could potentially grab some results from the future and combine them with the model's version of the past to produce a quasi baseline. It's not a great thing to do, and we haven't done that. And I'm just racking my brains at the moment to try and remember. Somebody on the line will know when the end point for the historic runs of the climate models is, but I think it's 2010. David Caroli will know. David said Darwin. Yes, it is. I nearly said Darwin. I didn't say Darwin because the AWAP data have a bigger error relative to the observed than elsewhere. But yes, that's right. Darwin will certainly be a location that doesn't have a match in the future within the country. Oh, thanks, David. The historic runs finish in 2005, or in some cases 2004. So there's a bit of a limitation there on the baselines we can choose. So it's not just about what historic data are available. It's a really good point. And maybe in the next, I don't know, as I said, whether the next set of modelling will have a different time frame for those runs or not. So yeah, watch the space unless somebody jumps onto the chat and fills in the answer to that one.
Okay, well, since I think we've just run out of time, we might end it there. Thank you very much, John, for an excellent presentation. And thank you everyone for attending. While I'm here, I would like to plug the next Earth Systems and Climate Change Hub Science webinar, which is happening next month on the 15th of May 2:30 to 3:30 again. The presentation will be given by Dr. Joe Brown from the Bureau of Meteorology on how will rainfall change in Northern Australia over the coming century. So stay tuned for information on that presentation. And thank you once again for attending.
Thanks, everyone.